Okay, this is the P2 paper from June 2024. It's question number 6, and as I scroll up and down, we can see this first part here is exponentials and logs. We're actually going to be trying to sketch this graph here on an axis. Then after we've done that, we're going to be looking at the integration chapter. We're actually going to use the trapezium rule to see if we can work out this area here. And then for the last part, we're going to be manipulating what we know about the trapezium rule to see if we can find the answers to C part 1 and part 2. Let's go back and just look at 6a though. And it says, can we sketch a curve with the equation y equals a to the x plus 4? Now, yeah, absolutely we can do that. They've given us a space down here to actually do it. So let's just talk about part A. Y equals a to the power of x plus 4. And then let's just quickly talk about what we know about these. Well, we know what e to the x, and so what a to the x looks like. E to the x is a quick sketch. As long as e is, what do they call it here? They say a is positive and greater than 1. So as long as it is that shape there, then we know that value there is going to be 1, and we know it's going to have that sort of shape to it. That would be e to the x, so hence that would be a to the x. And then when we do the plus 4, all that's going to mean is this graph is going to move up by 4 units. But what we'll need to know is what happens to that, and also what happens to this asymptote down here. So let's take a little bit more time over that now then, and show our working out for the examiner. First thing I would do is I would say for this, when x is equal to 0, we're going to get y equals a to the 0 plus 4, which is 1 plus 4, which equals 5. And for the asymptote, y asymptote is going to be at y equals 4. So if we put those two pieces of information into what we already knew previously from what I've just said, we'll be able to say sketch of this then is going to be y and x here. We're going to have that this is a curve that takes the shape of y equals e to the x, a to the x, whatever you want to say about it, and that this asymptote through here, which I'm now going to manipulate just with the iPad to make it look like a dotted line there. That asymptote, as we say, that's going to be at y equals 4. And this point here that we calculated, we could have said that it was 1, 0, and then added on 4, or the work that I've just done. But either way, this is the value 0.5 there. Let's just go back and check, I didn't spend too much time on it, that we've got both of those two pieces of information given on my sketch. Okay, let's have a look at the trapezium rule for the second part then. So it says part B, obtain an estimate for this thing here, giving our answer to 2 decimal places. So let's just make sure that from 2 to 3.5, from 2 to 3.5. So yeah, all my values are going to be within the table there, and what I'm going to want to do, which I generally tend to do on the table, is just to label these. I've got y0, y1, y2, y3, y4 and y5 when I'm subbing everything into the trapezium rule. So what is the trapezium rule then? The trapezium rule, let's go down and start doing our answer. For B, we want the integral between 3.5 and 2, or rather an estimate for the integral of this function, 2 to the x minus 2x dx. So that's going to be d over 2, and then it's the first one and the last one. So in this case, y0 and y5, sorry, handwriting, and then it's 2 lots of y1 plus y2 plus y3 plus y4. So that's the trapezium rule, and then actually I might move it over a little bit here. Think about what we've got to be writing down. So that's going to be equal to, we're just substituting everything in. The distance D is 0.3 from the table, and then we've got 0 plus 4.3137 plus 2 lots of all the others, and they are 0.3246, 0.8629, we've got 1.6643, and we've got 2.7896. So now, really carefully put all those values into your calculator. We only want it to 2 decimal places, and to 2 decimal places, apparently, it comes out to be 2.34. Okay, so that's the trapezium rule part done. And then it says, does this quite often with this part C here. Right, using what we found for this thing here, for part B, can we work out these 2 different ones? And what we know before we get started is that these 2 will be some sort of manipulation of what we have up in B here. So let's take a close look at this one. And what we've got is 2 to the x plus 2x. Actually, look, there's the difference on this first one. We've got plus 2x instead of minus 2x. And what we almost, your starting point is to think, well, that's what I know, so I've got to have that. I've got to have that start point and then see if I can get to plus 2x. So they take a little bit of practice. They take a little bit of going through and doing some of them, and maybe say, oh, I didn't realize I could do that. And then the next time you come to a question, you say, well, what did I do last time? So here, 3.5 and 2, what I actually want is 2 to the x plus 2x dx, but we have no possible way of doing that. You can't do anything to work out that value there. So what we need to do is to say, well, what can I do? I can do 3.52 2 to the x minus 2x. I know the answer to that. That's 2.34. So how do I get from here to here? What would I need to do to make those the same as each other now? Add 4x. You might need to stop and look at that for a while and go, oh, yeah, okay, that does actually work then, that if you do that. So that's the only thing I can do because I'm stuck with having this bit. I've got no choice but to have that bit. So adding 4x on there, and then you say, right, okay, well, now that I've got that, relatively straightforward to say, well, this is 3.52 2 to the x minus 2x, our original thing, but then plus just the integral of 4x between 3.52 and dx. And what we've now found is we know what that is already. That's our 2.34, and all of us can do that. All of us can integrate 4x and get the answer from that. So let's just finish it off. So that works out to be, well, it works out to be 2.4, doesn't it? Sorry, 2.34. 2.34 plus, well, what is the integral of 4x between 2 and 3.5? Well, the integral of 4x, add 1 onto the power, divide by the new power, becomes that. Well, I'm not even going to do all that. I'm going to write that as being 2x squared. So that's plus 2x squared being between 3.5 and 2, and then just stick those values in. Stick those values in. That works out to be 2.34 plus, that works out to be 16.5. And so the whole thing for that one works out to be 18.84. So that's how we do part 1. What about part 2? So part 2 then is saying the integral still between 3.5 and 2. That hasn't changed. And this time we've got 2 to the x plus 1 minus 4x dx. So again, what you've got to do is to almost look and say, well, what do I know? I know 2 to the x minus 2x. And so, as I say, this comes from experience, that what you can actually see here might be that you need me to do it and then go, all right, I didn't see it, but now I'll be looking out for it next time, is you could take 2 to the x plus 1 is actually 2 times 2 to the x, isn't it? That's the same thing. 2 to the x plus 1 is 2 to the x multiplied by 2. So if I take that out as a factor then, 2 taken out as a factor here gives me 2 to the x minus 2x dx. And then again, that's really clever then, because this bit here and this bit here was all the original thing that we had. So I've simply got that multiple of 2 in there. The multiple of 2 can come out of an integral. So I've got 2 lots of between 3.5 and 2 to the x minus 2x dx, which means then I've got 2 lots of my original thing, and my original thing was 2.34. So that means that the answer works out to be 4.68. So part 1 and part 2 there, so there's part 1 there. Part 1 and part 2 are quite clever. You need to have done some of those and just get the idea behind them. But the rest of that question should be fairly straightforward. Okay, hopefully that all makes sense to everybody.